use a graphing calculator to solve it. That is so. Is this equation the right one? The one I'm writing? That's the quadratic equation we want to solve. Before I continue. Huh? Is correct? It's the same thing. Maybe there is something that is missing which we cannot see. Oh, so when I get here, what do I get as answer here? Of this equation, what is A? 1 minus square root of 2 over 2 gives what? 0.29. Now you have to take the square root of this. Take the square root of this, let's see. What do you get? Okay, that's the problem. Wait, which one is wrong? No. Can you check? Just look again and tell me, your own work to tell me which one is correct. Pick Y. The square root of 0.29 is what? And that's your answer. Can somebody help us? Nelson, we need your help here. I'm a magician, right? But which one is correct? Maybe you can help. Which one is correct? 0.29 or 0.54? Why? Why do you think it's 0.29? No, solving this equation is the solution to this equation 0.29. Ready? You are looking for calculator? You see, calculator does not want you to use it. I know. There you go. Look at the equation the way I saw. What is A in respect to X? What is A How is A related to X? A is X squared, right? So, who is right? What is the right answer? Maggie, this calculator is not going to help you. It does not have to help you. Look at this equation. What is the solution to this equation? Look, the equation starts with x squared minus 4x equals to half. And I set it up to be x squared minus 4x squared plus 1 equals to 7. And I change it to a squared minus 4a plus 1 equals to 7. Then I find a equals to 0.29. Right. So which one is right? Jacob or me?
Well, you're both right.
Oh, good. We are both right. And we have to figure out. Mathematics is fun sometimes. Do you see what's happening? Until it feels like we are both right. And he's right. We are both right. Huh? We are both right. But it's just that, Jacob, you are right. The book is wrong because they copied this as their solution, which was not yet the solution. It's the square root of this, which is actually the solution. Do you understand? No? Huh? You see, I changed that. So I have to take the right answer. So you are using the calculator, and the calculator will always be right, right? If you put in the right thing. I was feeling to myself that why should I solve it again when the calculator have solved it? But Maggie, do you understand what we are saying? Yeah. So solving this, I surely make a mistake here. I was supposed to write A here, not X. I was trying to do it fast. So that's good. That's the reason why we do this homework. It's not really like to get the answer. It's just to, to understand some of these things. So Jacob, you are right. Send them a letter. Say this answer is not correct. The answer is 0.454. Those answers generally are made by students, and they will send it to a professor to check. They give me a whole book to check the answers. In 2 weeks, I can't check all those answers. Sometimes I correct as many as I can, but I believe there are still more that are there that might not be correct. So don't always trust the answer at the back of the book. Yeah, okay, that works fine, right? Thank you. I'm sure you were convinced you are doing the right thing. So if you are not done with it, we can submit it on Friday. Not really like, I prefer you do the work, don't be rushing it. Is that okay for everybody? And then I will send you the take-home problem. You will have to be working on both at the same time. All you learn, in all of those work you learn. So it's not like you must do one before the other. Don't focus only on the take-home problem. We were on chapter 6, I think. Let's find the median of an exponential distribution together. At this point, honestly, I am sure, should I just teach more or do more problems? Find the median of x if x is an exponential distribution. Find the median of x if x is an exponential distribution. An exponential distribution is f of x equal to lambda e to the minus lambda x. Remember, we solved that the cumulative distribution function of x was f of x equal to 1 minus lambda x. You can remember that. This guy is lambda. Oh, I'm sorry. This is lambda I'm trying to write here. We did this last time, the cumulative distribution of an exponential distribution. This is the cumulative distribution. As Jacob did there, we will solve it equals to half to find the median. The median is the solution of f of x equal to 1 over 2. That is 1 minus e minus lambda x equals to 1 over 2. That is 1 minus 1 over 2 equal to minus. That is 1 over 2 equal to e to the minus lambda x. So minus lambda x is equals to logarithm of half, which is minus logarithm of 2. So we can see that x equals to logarithm of 2 divided by lambda. Each time you have an exponential distribution, or you are asked for the median in general, the median is logarithm of 2 divided by lambda. For that polynomial density function, it was a little bit complicated. And it was easier than some other polynomials that we may have anyway to solve the one Jacob solved. If we are asked to find the mode of an exponential distribution, think about the mode. To find the mode of an exponential distribution, the mode is the value, the random value with the highest density value, density function. So we are going to say that we will have f of x equals to lambda e to the minus lambda x. And what will be f prime of x? Minus lambda square e to the minus lambda x. Is that right for the derivative of the density of an exponential? Is the derivative correct? The derivative of this function, can I say is this one? Can I say is this? Derivative of e to the ax is a e to the ax. Is this derivative a positive or a negative function? Can it be 0? Can this function be 0? The derivative, can it be 0? Cannot be 0. Most of the time when we are looking for the mode, we are looking for the point where the function attains its maximum. So we normally set the derivative equal to 0. In this case, the derivative cannot be 0, but we will look at the endpoints. The domain of an exponential distribution is 0 to infinity. The only endpoint is 0. So we want to check if that 0 is actually the maximum. This is a negative derivative. What does it tell us about the function itself? How do we get the maximum or the minimum of a monotonic function? You know, monotonic, that is either all increasing or all decreasing. When the derivative is either positive or negative, you have a monotonic function. So that means it will continue either to increase or to decrease. This one, is it a decreasing or an increasing function? It is decreasing. So the maximum will be where? The largest value of the function will be at what point? Where it begins or where it ends? Where it begins, because decreasing. So the mode is 0. F prime is negative. So the mode is f of 0. Okay. So we have looked at some of those values. Now let's think about a property. I wanted to do that last time. We didn't have the time. The memoryless property. Of the exponential distribution. Says that the probability that x is greater than a plus b, given that x is greater than a, is just the same as the probability that x is greater than b. Think about it, an example like this. Let's say two people, A and B, take a bus at the same bus stop. When you are in big schools, they have bus stops all over the campus. So when you get to the bus stop, you begin to be thinking, did I come early? How long until the bus arrives? The time until the bus arrives is an exponential distribution. So if you know the average number of time the bus arrives, you can be able to tell the probability that the bus will arrive within a certain fraction of time. Suppose that A arrives at noon and B arrives 5 minutes later. What is the probability that B is going to wait for 15 minutes, given that A has already been there for 5 minutes? So probability that x is greater than 15, given that x is greater than 5. What I'm saying is the same as probability that x is greater than 10. This is just a practical example of what I'm talking about. So the time that has elapsed does not really matter. That's why we call memoryless property. It doesn't count what was there before. So let's check that. We will do probability that x is greater than a plus b. I can still write a plus b plus a. A plus b, given that x is greater than a. Both a and b are positive because it's a non-negative random variable. It's equal to probability that x is greater than a plus b, because given a, we would have said probability that x is greater than a plus b and x is greater than a, which is that x is greater than a plus b. What I mean is, if this is 0, this is A, and this is B, A plus B will be something somewhere here. So saying that X is greater than A plus B is this part. Saying that X is greater than, I don't even know where B could even be here. So their position does not really matter. But if two numbers are positive, their sum is bigger than any of the two. So for that reason, X greater than A plus B intersection X greater than A equals to X greater than A plus B. If we have that, then we are going to divide by probability that X is greater than A. Remember that probability of A given B is probability of A intersection B divided by probability of B. And this is equal to, this one is what we may call, anyway. So probability of X greater than A is equal to 1 minus probability of X less than or equal to, which is 1 minus f of A. Remember, f of A was 1 minus e to the lambda x. So this will be 1 minus 1 plus e to the minus lambda A. We did something similar to this with geometric distribution. So probability that X is greater than A, we are saying is exponential minus lambda A. So that probability that X is greater than A plus B, given that X is greater than A, equals to what we have here is e to the minus lambda A plus B divided by e to the minus lambda A. You can check this one. This is e to the minus lambda A times e to the minus lambda B over e to the minus lambda A, which is e to the minus lambda B, and which is probability that X is greater than B from what we did up here. This is just a simple proof of the property of exponential function, which is similar to that of a geometric distribution. They have a memoryless property. So sometimes you may know probability that X is greater than B, and you are asked to find probability that X is greater than A plus B, given that X is greater than A. That A does not really matter. That given that X is greater than A does not really matter. So 6.3, we really need to get to 6.3, especially for Jacob, who will be saying goodbye to maths. The probability. It's good to know normal distribution. Normal distribution. In STAT 205, Anthony, are you taking him at 215? Introductory statistics? If you have planned to do, if you have space, you can register for it. It's an easy class. So I just tell them a normal distribution is a distribution with a bell-shaped curve. We move on. But here we have to work a little more. We will do some mathematics for the remaining 15 minutes. At least I will prove something. So find a constant. I like this type of question. Find a constant a so that the function f of z equals to a exponential minus z squared over 2 is a density function on R. Have you all done differential equation? You did differential equation with me? Okay, there was something that I defined as error function. You might have forgotten because people are not using it a lot. Error function are a little bit like cosine, sine. I mean, those type of function that exponential, we just define it and use it. You cannot really say that you know how to compute it. So when we were doing error function, we do find the integral of this. So this is a density function if the integral from negative infinity to infinity of k minus z squared over 2 dz is equals to 1. We are going to find this integral and solve for k. So I will say show that the integral from negative infinity to infinity e of minus z squared over 2 dz is equals to square root of 2 pi. Look like a common integral, but it is not. The error function, we say negative infinity to x, fixing it like the cumulative of this. Okay, we want to compute this integral. Have you done multiple variable calculus? Anybody? Calculus 4? You have not done calculus 4. Calculus 3. I think it's calculus 3. I don't know. Have you done multiple integrals? Multiple in calculus 3. We are going to use multiple integrals here. So I will say that A be equal to the integral from negative infinity to infinity e to the minus z squared over 2 dz. E to the minus z squared over 2 is a non-negative function. Can we agree on that? Exponential is always non-negative. The integral of a non-negative function is, the integral is not that it's always positive, but if you take it as an area, it will be positive. If it is positive, it means that it is above. This is how the graph will be. It is above the x-axis. So we are going to consider it as a positive function. Multiply a by a. A square will be negative infinity to infinity, e to the minus z square over 2 dz times negative infinity to infinity, e to the minus z square over 2 dz. This is a square, right? I multiply a by a. So we are going to give different variable to x to z here. We will put x and y to both integral. I will write it as negative infinity to infinity, e to the minus x square, e to the minus x square over 2 dx, and negative infinity to infinity, e to the minus y square over 2 dy. There is a theorem in calculus that tells you that if this integral is finite, you can put them again back together. Actually, what you learn from integral is that you can separate them. They call it Fubini's theorem. Maybe they would not have given you that name, but if you can separate them into two, we will put them back as a double integral. And it will be minus x squared over 2 e to the minus y squared over 2 dx dy, which is integral of negative infinity to infinity, double integral e to the minus x squared plus y squared over 2 dx dy. I have switched that integral back to a double integral. That's why I asked if you have done multiple integrals. Now we will do change of variable. You remember change of variable? Sometimes we call it the chain rule in differential equation. But now it's two variables. It's not as smooth as for one variable. So change to polar coordinates. You remember polar coordinates? Polar coordinates. It's equals to r cosine of theta, I equals to r sine of theta. Then x squared plus y squared is equals to r squared. R positive as a radius. This is x, this is y, this is r. So r cosine of theta, this theta is here. X is r cosine theta, and y is, that's polar coordinate, if you could remember that. Now, dx dy is equals to the absolute value of the Jacobian dr d theta. When you are doing the change of variable, you will remember this. Where this Jacobian is the determinant x over r x theta y r y theta. In differential equation, you would have learned about the Jacobian. Or you use something like the Roskian in differential equation. It's something like the Roskian. So, what is the derivative of x with respect to r? X equals to r cosine of theta. What is the derivative of x with respect to r? You take anything else as constant in multiple variable and find the derivative with respect to r. This is x. What is the derivative of this expression with respect to r? Take cosine of theta as a constant. What will it be? Partial derivative. If it was derivative of r cosine of theta with respect to r, theta is a constant. It's cosine theta. Cosine theta. And derivative of x with respect to theta, r is constant now. Minus r sine theta. And derivative of y with respect to theta. Derivative of y with respect, derivative of y with respect to r. With respect sine theta. And then the derivative of y with respect to theta. Great. That means you guys know your derivative of trigonometry. So now we do the determinant here. Look at what the determinant we give. R cosine square of theta plus r sine square of theta. Remember the determinant, you do minus, the minus of minus. And this is r times sine square of theta plus sine square of theta, factoring r out, which is equal to r. So this Jacobian is r, is positive, so when we are doing this, we will say that r is positive. When you are changing in the polar coordinate, r is the radius. And theta is from 0 to 2 pi. R is from, theta is from 0 to 2 pi, right? So look at this integral. That's what I'm changing. This integral is going to become integral from 0 to pi for theta, from 0 to 2 pi. This is minus infinity to infinity, changed from 0 to 2 pi. An integral from 0 infinity for r. The limit of r is 0 to infinity. And now x squared plus y squared now is r. Sorry, here. Yeah. Square is r square cosine square. Y square is r square sine square. So here, I want to save the writing. Here, x square plus y square will be what? R square. We know that, right? So this integral is going to be e to the minus r square over 2 times r, using this change of variable here. This j is now r, is r dr d theta. I'm sorry for, let me remove this one. You already have that, so I can take this away. So now look at this. Look at this part. What is the derivative of r squared over 2? This r e to the minus r squared over 2. The derivative of this is that. So that's kind of what we are seeing here. This r times that. So this is 0 to 2 pi. And this part is going to be minus r. This minus comes here. Not minus, I'm sorry. Look, this r times that. I am taking this minus here and put e to the minus r squared over 2 from 0 to infinity. Now d theta. So at infinity, what do we have here? At infinity, what will this be, Jacob? Just like we did for the exponential last time. It will be 0 at infinity. And at 0, it will be minus 1. So we are going to do minus, and it will become 1. It will be 0 to 2 pi. This thing, when you are fast, it doesn't write. Theta, right? You can complete this. Good. If I can achieve this, I will feel good if we end the class today. So that you see sometimes how some of those things we are learning could come together to help. I will send you some questions. Oh, you are done. I will send you the take-home problems. I will put maybe 1 or 2 problems for normal distribution. I will explain. You can do those things, even normal distribution.